Alright, so now we're going to take a look at the mass on a spring, simple harmonic motion. So the period formula, period, T is the period. Period is equal to 2 pi times the square root of mass over K. Well, this is to say the period is the time for one cycle. And you consider one cycle as if we pull the mass down to its maximum displacement, and we'll call that negative, and it goes through the equilibrium point and passes through and hits its maximum displacement up here, which is, we're going to call that positive maximum displacement, negative maximum displacement. So if we pull it down to maximum negative displacement, allow it to go through the equilibrium to maximum positive displacement, back through the equilibrium and back here. So our start and stop are in the same place. That is the definition of one cycle. So the time that it takes for that to go is this formula right here. What happens if we know the time and we know the spring constant, K, is a spring constant measured in force per meter stretched. So Hooke's law, force equals Kx. X is the meters of stretch, force is the amount of force applied, and K is the spring constant. K is F over M. M is meters, force per meters, that's how it's measured. So what if we know the spring constant, we know the period, so let's rearrange the equation, solve for K. If we happen to know the mass and the spring or the period, mass in this period, and we wanted to solve for K, we could. So then T over 2 pi, because we're dividing both sides by 2 pi, equals square root of mass over K. So we're going to isolate K here. We're going to square both sides, so we get T squared over, remember 2 pi quantity squared would be 2 squared, which is 4 times pi squared. So that side is squared, equals M over K. Now, what I was telling you before, if we move this over across the equal sign, we just move it diagonally. And this whole quantity we're going to move across the equal sign diagonally. So then K is equal to M over this whole thing on this side. So that would be T squared over 4 pi squared. Now we have a denominator, which is a fraction, so we pull the denominator of the denominator to the top, so this really becomes K is equal to 4 pi squared M over T squared. Okay, so here we have K is your spring constant, 4 pi squared times the mass divided by the period squared. What if we wanted to solve for M though? Solve for M. A little simpler process. If we go back to a step where we are here, we could just jump right in and say T squared over 4 pi squared equals M over K over 4 pi squared equals M over K. So now it's solving for M, we just multiply both sides by K. So the K's cancel. So M is equal to KT squared over 4 pi squared. Now the bit of caution here is to remember again, like we had with the pendulum, put 4 pi squared in parentheses, otherwise you're taking K, the spring constant, times the period squared divided by 4, and then you're multiplying all that by pi squared. That's not going to be correct. So if we do spring constant times period squared divided by quantity, 4 pi squared, then we'll come out with the mass.